start the class.
సార్ ఇది మ్యూట్ లో ఉందా లేదా ఎలా తెలుస్తుంది సార్? వాయిస్ వస్తుందా లేదా? Good morning, children. Hearty welcome to today's maths class. Today, we are celebrating National Mathematics Day. National Mathematics Day is celebrated on Srinivasa Ramanujan's birthday, recognition of his contribution to mathematics. He made great contributions to the mathematical analysis, number theory, infinite series, and continued fractions. He also compiled nearly 3,900 results such as the Ramanujan prime, the Ramanujan theta function, partition formula, and Mach theta functions, etc. An equation has no meaning for me unless it expresses thought of God, says Ramanujan sir. National Mathematics Day. On 125th anniversary of Srinivasa Ramanujan Iyengar's birthday, India declared the birthday of Sri Ramanujan sir 22nd December as National Mathematics Day. The declaration was made by Dr. Manmohan Singh in Chennai on 26th December 2011. Dr. Manmohan Singh also declared that the year 2012 would be celebrated as the National Mathematics Year. Children, this is one of the papers that we have got in the collection of Srinivasa Ramanujan's written works. He used to solve the problems or the statements that came into his thoughts on rough papers like this, giving page numbers. Children, 1729 is known as Hardy Ramanujan number. We all know it. The reason why this number is called is very important. It is sometimes is also asked in group 1 exams in interviews. The smallest number expressible as the sum of the two cubes in two different ways. 1729 is equal to 1 cube plus 12 cube and is also can be expressed as 9 cube plus 10 cube. So these are the two different ways in which 1729 is expressed. And 1729 is the smallest number that is expressed in this way. There are many other numbers which can be expressed in this form, but 1729 is the smallest among all those numbers. So this is the brief introduction about Srinivasa Ramanujan, children. Happy National Mathematics Day once again, children. Take the inspiration from great mathematicians of India and all over the country and be a great mathematicians in your future ahead. Let us start today's permutations and combination class for children. Today, we revised the class that we discussed earlier in class 3. We were discussing the rank problem. It is very, very important problem in intermediate public examination point of view. Dear children, what is the rank problem? If we are given a word and if we arrange the letters of the given word in alphabetical order, if I arrange the words in alphabetical order and we have to check present comes after how many terms, after how many words. Let us solve a problem. If the letters of the word present are permuted in all possible ways and words thus formed are arranged in dictionary order, that means we have to arrange the words start from P, arrange the words start from R, arrange the words that start from I, arrange the words start from S, and find the words start from O, and find the words start from N, and arrange them in a dictionary order. Then we have to find the rank of the word present. Let us see how to do the problem once again. Solution. The letters of the given word in the dictionary order is, first we have to check, we have to go for alphabetical order. When we go for alphabetical order, what is the first letter that come in present? P, R, I, S, O, N are the alphabetical words. In alphabetical order, I comes first. This is the first come. A, B, C, D, E, F, G, H, I. After I, J, K, L, M, N. After N, O, P, Q is not there, then R, then S. Like that, we have to check alphabetical order. First comes I, next comes N, next O, next P, next R, next S. With this, we have finished all the words of the present. Step 1 is to write the letters of the given word in the dictionary order. In the dictionary order, first we write all the words that begin with I. Because in the dictionary order, now we have I, we shall start the words with I, children. If we fill the first place with I, then the remaining 5 places, total number of the letters. See children, how many letters are there here? Here it is 1, 2, 3, 4, 5, and then it is 6. Now we are talking about the words that fill with I only. Okay. Now in the dictionary order, first we write all the words that begin with I. After I, how many words we shall write, children? In the dictionary order, first we write all the words that begin with I. If we fill the first place with I, then the remaining 5 places. See here, children. After I, how many places are there? 1, 2, 3, 4, 5. So out of 6 letters, if I is taken out, there are 5 places. These 5 places should be filled with 5 letters. N, O, P, R, S. So 5 places with 5 letters. How many ways? It is 5 factorial ways. We shall take a box and then first word is filled with I. Now this is 1 place and this is 2nd place. This is 3rd place. This is 4th place. 1, 2, 3, 4, 5. These 5 blanks are now filled with 5 letters N, O, P, R, S. 5 places and 5 letters. So how many kinds of permutations? 5 factorial ways. That is, there are 5 factorial words that begin with only I, children. Now we have to proceed like this. After I, what is the next letter in the alphabet? N. In the dictionary order, the next alphabet is N. So same, we have to draw the box, and instead of I, now we shall fill the first box with N. That is also 5 factorial. And then O. That is also 5 factorial. After I, N, O, we shall start. We have to write the words begin with P, children. But P is P is present and is the first letter of the required word prison. Whenever our required letter appears, then we have to continue taking the next letter. In alphabetical word, what is the next letter? This is I. After P, again, then we have to take P and I. This I, for the second place, since P is taken, among them, first comes the words with the 2 letters P-I. As above, there are 4 factorial such words. And proceeding like this, we get, see here children, only when there is I, since there are 5 dashes, it is 5, and 5 words, it is 5 factorial words. Similarly, for the single letter N, we'll get 5 factorial. For O also, it is 5 factorial. But when turn of P comes, what shall we keep in our mind? P is present in prison, the first letter. So whenever the required term has come, we have to move again. Since we have to move again, we take the first alphabetical order again. So what comes after P? I again. Second letter. Now the fixing of the first letter is over. Now second letter is to be fixed. So it is P-I. After fixing P and I, how many blanks appear on the screen? 4 blanks. Therefore, there are 1, 2, 3, 4 factorial words, children. Now, after I, what is the alphabetical order? N. So P is fixed. We don't change P because P is the letter with which our required word starts. Now we start with N. P-N. How many such words? 4 factorial words. Why 4 factorial? There are 4 blanks and we have 4 more letters. So the required permutations are 4 factorial. Now, dear children, after I, N, what comes? O. Similarly, there are 4 factorial words with P-O. Now, I is over, N is over, O is over, and P is already fixed. So, what comes next in the second place is R. But PR is the required combination in the given letter prison. Therefore, we fix R also. Whenever we got the required word, we fix it. We don't change it order. Now, when we fix the second letter R, again we shall go to the beginning, taking dictionary order. What is the beginning alphabetical order? I. Therefore, P-R-I. If we observe, P-R-I is also there in the required word prison. So, P-R-I are fixed. Now, 3 letters got fixed in this step. P-R-I is over. Again, go for the alphabetical order. After I, what comes, children? N. Prin. So, now P-R-I after N. How many blanks appear in this 1, 2, 3, 4, 5, 6 letter word? 2 blanks only are there. And how many letters are remained? 2 letters only, O and S. So, 2 blanks are filled with the 2 letters in 2 factorial ways, children. Now, next step, P-R-I. After N, which is the alphabetical order letter? O. So, P-R-I-O. With this combination, how many words are going to come? 2 factorial words. Now, after O, what is the alphabetical letter? That is S. P-R-I-S. Now, we fix this S also because this is the alphabetical order required to make the prison word. So, fix S also. How many letters are fixed now? P is fixed, R is fixed, I is fixed, and also S is fixed. P-R-I-S. After fixing this word, again go for the alphabetical order. Going to the alphabetical order on top, I is already fixed, then again N. Fix N. Now we write N. Only one blank is there and one more letter is left out, O. So one place with one letter is only 1 factorial. Now we shall come to the next step. P, R, I, S. After N, which is alphabetical word? Alphabetical letter O. But P, R, I, S, O is present in the present. Therefore, we'll continue writing the next alphabetical letter, which is N, alphabetical order letter N. Thus form the word prison. That is only one word. Now, see the screen, children. How many 5 factorial words are there? 3. How many 4 factorial words are there? 3. How many 2 factorial words are there? 2. How many 1 factorial words are there? 2. 1 factorial is same, 1. So, let us add all these so as to find the rank. Hence, the rank of the word prison is 3 into 5 factorial plus 3 into 4 factorial plus 2 into 2 factorial plus 1 factorial plus 1. What is 5 factorial, children? 5 into 4 into 3 into 2 into 1. From 5, taking 5 as the highest, n factorial is taking n as the highest number, write the successive multiples in decreasing order. 5, 4, 3, 2, 1. Their product. 4 factorial, 4 into 3 into 2 into 1. Like that. 3 into 120 is 360. 3 into 24 is 722. 2 into 2 is 4 and 1 plus 1 is 2. Summing up, it is 438. Hence, the rank of the word prison is 438. This is a small recapitulation of how to find the rank. Dear children, let us move to the next question. Find the number of the 4-digit numbers that can be formed using the digits 2, 3, 5, 6, 8 without repetition. It is very, very important, children. Whatever the problem we are doing is without repetition. None of the digit is taken again and again. How many of them are divisible by 2? Divisible by 3. How many of them are divisible by 4? How many of them are divisible by 5? And how many of them are divisible by 25? Dear children, for this question, let us find first the number of the words. Then how many divisible by 2, 3, 4, 5, 25 can be calculated. First we should know total how many words can be, how many numbers can be formed with the given digit. How many 4-digit number can be formed with the given digits. Dear children, to do this problem, you have to revise the divisibility rules of the numbers. Solution. The number of the 4-digit numbers that can be formed using the 5 digits. What are the 5 digits, children? 2, 3, 5, 6, 8. How many digits are there? There are 5 digits. But out of these 5 digits, we have to take only 4 at a time, because to make a 4-digit number, we need only 4 digits. So take only 4 digits out of this 5. What is that selection called? What is that permutation called? Sorry. That permutation is NPR, which is 5PR. How can we simplify this? 5 into 4 into 3 into 2. 4 multiples, which is 120. Therefore, the number of 4-digit numbers that can be formed using the digits 2, 3, 5, 6, 8 is 120. Now, we have to see how many numbers are divisible by 2. For a number, we have to check the divisibility rule. What is the divisibility rule, children? For a number to be divisible by 2, the unit place should be filled with an even digit. Unit place should be filled with an even digit. This can be done in 3 ways. 2 or 6 or 8. Look at the box, children. How many boxes are there? 4 boxes are there because it is a 4-digit number. And it is even when the ones place is filled with an even number. What are the even digits in the given digits? 2, 6, 8. So the cross mark is kept To make you understand that the cross mark ones place digit of the given 4-digit number should be placed either with 2 or with 6 or with 8. So how many ways? 3 ways. Now how many places are remained, children? 3 places are remained. How many numbers are remained? That now the remaining 3 places can be filled with the remaining 4-digit numbers, such as 4P3, which is 24 ways. When we kept 2 here in into place, we have 4 digits. So the 3 places are filled using 4 digits, which is 4P3. Hence, the number of 4-digit number divisible by 2 is 3 into 24. In the first way, it is 3 ways, 2 or 6 or 8. In this selection, we got 3 ways. After fixing units digits, the remaining 3 places are filled with the given 4-digit numbers in 24 ways. So, the total number of 4-digit numbers will be the product of these two, 3 into 24, which is 72. Now, the next question is how to check the given how many numbers are divisible by 3. Now, we have to check the divisibility rule of 3, children. When can we say that the given number is divisible by 3? A number is divisible by 3 if the sum of the digits in its multiple is multiple of 3. Since the sum of the given digits is 24. Children, what are our given digits? What are our given digits, children? 2, 3, 2, 3, 5, 6, 8. Add them, children. 2 plus 3 plus 5 plus 6 plus 8, which is divisible by 3. 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 6 is 16. 16 plus 8 is 24. So the sum of the digits is 24. We have to leave either 3 or 6. Children, it is very important statement, children. Why should we leave 3 or 6? Because 24 is divisible by 3. Only 3 multiples should be left, so that the result number will be divisible by 3. What are the 3 multiples in the given number? 3 and 6. So only these numbers should be subtract. This number should be left from the given number, so as to make a 4-digit number as well as a multiple of 3. So leaving 3, we will get the required words as 2, 5, 5, 8. The first combination 2, 5, 6, 8 is obtained leaving 3, children. And the second combination 2, 3, 5, 8 is obtained leaving 6. So like that, there are 2 combinations. In each case, we can permute them in 4 factorial. These are the 4 digits in the first case and 4 digits in the second case. And we also need 4-digit number. So 4 blanks and 4 digits. How many ways we can permute? In 4 factorial ways. That the number of the 4-digit numbers divisible by 3 is 4 factorial in the first case, 4 factorial in the second case, so that it is 2 into 4 factorial. What is 4 factorial? 4 into 3 into 2 into 1. 2 into 24, which is 48. Now divisible rule of 4, children. A number is divisible by 4 if the number formed by the digits in the last 2 places is a multiple of 4. We have to check the divisibility rule of 4 for the given numbers. When can we say a given 4-digit number is a is divisible by 4, children? We'll check the last two places of the given number. If those last two places are divisible by 4, then the given number is divisible by 4. So let us check all the 4-digit numbers that can be formed, all the 2-digit numbers that can be formed which are divisible by 4. First we shall write the given digits here, children. 2, 3, 5, 6, 8. Now with 2, we will take the combination of 3. What is the word formed? 23. Is it divisible by 4? No. So we shall not take this word, children. We shall not take this number. Now 2 with 5. 25 is also not divisible by 4. So we don't consider, children. Now 2 with 6. 26. Is it divisible, children? Is it divisible by 4? No. So we don't consider this. Now 2 with 8, children. Which is the number formed? 28. Yes, 28 is divisible by 4. So we shall take 28 as the required number. Similarly, 3. Now take 3. Now 3 with 2. 32. Yes, that is the required number because 32 is divisible by 4. So let us take 32. Now 3 with 5. 35 is not divisible by 4, so we don't consider this. Now 3 with 6, 36. Yes, 4 9s are 36. Therefore, 36 is the required number. Now 3 with 8. What can we do? 3 with 8, 38. No, it is not possible. It is not divisible by 4, so we don't take, children. Now 2 is over, 3 is over. Now we'll select 5. Orderly we will go. 5 with 2, 52. Yes, it is divisible by 2. Therefore, we will take 52. After 5, 2. Now let us take 5, 3, children. 53. No, it is not divisible by 4. So we don't consider 53. Now 5 with 6, children. 56. Yes, 56 is divisible by 4. So 56 is considered. Now after 5 with 6, now we shall go with the combination 5 with 8. 58 is not divisible by 4, so we don't consider. Now the combination goes with 6. 6 with 2, 62 is not divisible by 4, so not considered. 63 is also not divisible by 4. 65 is also not divisible by 4. 68 is divisible by 4. Therefore, 68 is considered. Like that, we have to get all the 2-digit numbers which are divisible by 4 that are formed with the given digits only. Is this clear, children? How many ways it is done? 6 ways. 28. 1, 2, 3, 4, 5, 6. So, this last 2 digits are filled in how many ways, children? 6 ways. Now, after filling the last 2 places, there are 2 remaining places here. In the box, how many places are remaining? 2. Now, how many digits are there? 1, 2, 3, 4, 5. In these 5 digits, 2 are given here. So, the remaining are 3 only. In this remaining 3 digits, we have to fill 2 places. So, 3P2 is the required permutation. How many ways? 6 ways. So, here it is 6 ways and before it is 6 ways. The first 2 places in 6 ways and the next 2 places in 6 ways. So, the total, the number of 4-digit number divisible by 4 is now 6 into 6, 36. 36 ways. Now, we'll go with divisibility by 5. Let us check the divisibility, how many numbers are divisible by 5. What is the divisibility rule of 5, children? In the last units place, there should be either 5 or 0. But in the given numbers, there is no 0. So only 5 should be placed in the unit places. So after filling the unit place with 5, how many places are remaining in 4-digit number? 1 is filled with 5. So out of 4-digit number, 1 digit is filled. So the remaining 3 places can be filled with 4 digits, which is in the form of 4p3, 24 ways. Hence, the number of 4-digit number divisible by 5 is 24. I'll just write it above so that you can understand it. Let us take a box, children. In that, how many digits? 4 digits. First digit, second digit, third digit, and fourth digit. This fourth digit is filled with 5. Now, 1, 2, 3. These are the 3 places remained. These 3 places are remained with how many digits? Maybe with 2, maybe with 3, maybe with 6, and maybe with 8. We don't take 5 now because 5 is already here. So how many digits are available? 4 digits are available. And only how many places should be filled? 3 places. So what are the permutations? What are the number of the permutations? 4p3. So taking 3 at a time out of 4. So this is nothing but 24 ways. Hence the number of the 4-digit numbers divisible by 5 is 24. Now divisibility by 25. Divisible by, let us check how many numbers are divisible by 25. Here also we have to fill the last 2 places with the 25, children, because divisibility rule 25 for this numbers 2, 3, 5, 6, 8 is, see, we can also have 0 in the units place. Since 0 is not given in the given digits 2, 3, 5, 6, 8 won't contain 0. For this problem, the last 2 digits must be 25. Only then the numbers formed will be divided by 25. Now, out of 4-digit numbers, 2 places are filled with 25. Last 10th place and 1's place are filled. Now, 100th place and 1000th place is remained. 2 places are remained. Numbers are 3. So, now the remaining 2 places can be filled with the remaining 3 digits in 3p2, which is equal to 6 ways. Hence, the number 4-digit number divisible by 25 is 6 ways. See the diagram, children. See the box. The last 2 digits are divisible. The last 2 digits are fixed. 2, 5. Only 2 digits are remained. The first 2 digits, 100th place and 1000th place. There are 3 more digits. What are 3 more digits? 3, 6, 8. So taking 2 at a time, it is 3p2, 6 ways. Now let us take the next question, children. Find the sum of all 4 digits number that can be formed using the digits 1, 3, 5, 7, 9. This is very, very, very important, children. Please try to understand by adding the numbers mean adding their ones places, adding their tens places, adding their hundreds places. How do we add the numbers given digits? Suppose I have 25 and 26. First I will add 5 and 6 unit places and then come for the tens places. So that concept is used to solve this problem, children. We know that the number of the 4-digit number that can be formed using the given 5 digits. How many digits are there, children? 1, 3, 5, 7, 9. Count, it is 5 digits. But how many digit number you want? 4-digit number. So 1, 2, 3, 4, 5. Out of these 5 digits, we need only 4 at a time. What is that permutation called? What is that process of permutation? 5p4. In how many ways we can select? 5p4, which is 120. Now these all are 4 numbers. Should be and first add all the numbers in the unit digit, then tens digit, then hundred digit, then thousand digit. The unit place. Let us take the small number. What is the smallest digit? Sir, host privilege दीजिए. Now we shall fill the last digit with 1 children. And how many places to be filled now? 3 places to be filled. And these 3 places should be filled by taking 4 digits. By taking the digits among the 4 digits. How many ways? 4p3 ways. This means the number of 4-digit number having 1 in unit places is 4p3 ways. Similarly, instead of 1, we can keep 3 also in that place, 5 also, 7 also, 9 also. So all these can be placed in unit digits. How many ways? 20 appear 24 times in units place. 4p3 means it is 24. 4 into 3, 12, 12 to 24. By adding all these digits, we get sum of the digits in unit places of all 120 numbers. So we now got the process of finding the sum of all unit digits. First we fix 1. How many types we can fix? 4p3 ways. Why 1? We can also fix 3. We can also fix 5. We can also fix 7. We can also fix 9. Like that. So like that. 4p3 into 1. So fixing 1 in unit place. Now fixing 3 in unit place. Fixing 5 in unit place. Fixing 7 in unit place. Fixing 9 in unit place. So 4p3 can be taken out, children, taken as a common. Then it is 1 plus 3 plus 5 plus 7 plus 9. It is 25. That means 4p3 into 25 is the sum of the digits in the ones place of given words, given 120 words. Now we have to find, after summing up ones place, we have to go with the tens place. Now tens place will also be same, except that the value of this number 4p3 into 25 is multiplied with 10, because the same digits are filled in tens place also. And the same kind of arrangement takes place in the thousands digits. Therefore, similarly, we get that the sum of the digits in tens place as 4p3 into 25, and its value will be multiplied with 10 when it is tens place. And when it is hundredth place, the same value is multiplied with 100, and when it is thousandth place, the same value is multiplied with 1000. Now we have to sum up all these. 4p3 into 25 into 1 is the sum of the digits in the units place. Now it is in tens place into 10. Now this 4p3 into 25 into 100 is sum of the digits of hundredth place. Now 4p3 into 25 into 1000 is sum of the digits in thousands place. So adding all this, we can take 4p3 into 25 common. Then it is 1 plus 10 plus 100 plus 1000, which will be 1111 multiplied with 4p3 into 25. But 4p3 is 4 into 3 into 2. Starting from 4, 3 successive multiples. 4, 3, 2 in a decreasing order. 24 into 25 into 1111, which will be 6,66,600. Now we shall see an important generalization using this problem. In this above problem, we can derive, using this above problem, we can derive that sum of all r-digit numbers are, if the number of the digits are r, that can be formed using the given n non-zero digits, and the value of r and n should follow like this. 1 is less than or equal to r less than or equal to n less than or equal to 9. Then the shortcut, the formula to write the required sum is n minus 1 p r minus 1 into sum of the given digits into all ones. How many times this ones should be taken a number? R times. Look at the number of the digits so that it is obtained. So using this concept, we can, in MSET, we can directly write the question. See here, 1, 3, 5, 7, 9. So it is 5 digit number. There are 5 digits in the given number. 1, 3, 5, 7, 9. Reduce one number out of that. So it is 4. So it is 4p, and this is 4 digit number. Reduce 1 out of that. N minus 1 p r minus 1. So it is 4p3 into sum of the digits. 1 plus 3 plus 5 plus 7 plus 9, which is 25. Because it is 4 digit numbers, multiply this with 4 ones. 1, 2, 3, 4. This is how we will get the formula. In the above problem, in the above generalization, if 0 is also one digit among the given n digits, 0 is not there in our problem. But if 0 happens to be one of the digits, then there is another formula. We get that the sum of the odd digit numbers that can be formed using the given n digits, including 0. That means if 0 is calculated in the unit digits, those numbers should be subtracted. What are those? How can we get that sum? Using the formula n minus 1 p r minus 1 into sum of the given digits into 1, 1, 1 and so on 1 r times. Out of these, some number should be subtracted. What are those? Minus of n minus 2 p r minus 2 into sum of the given digits into 1, 1, 1 and so on. R minus 1 terms. The r minus 1 times. These many numbers should be subtracted. Dear children, next question is, how many 4-digit numbers can be formed using the digits 1, 2, 5, 7, 8, 9? How many of them begin with 9 and end with 2? It's very simple, children. See here, First we have to write the given digits. Given digits 1, 2, 5, 7, 8, 9. Count how many are there? 1, 2, 3, 4, 5, 6 digits are 6 given digits. But how many digit number you want to form? Sir asked us to find 4-digit number. So we have to take 4 digits at a time. Out of 6, how many at a time should be chosen? 4. So what are the how many ways? 6p4. What is the value of 6p4, children? 6 into 5 into 4, which is 360. 6p4 ways. Now, the first word 6p4 is 6 factorial, 6 into 5 into 4 into 3. 4 successive in a multiples in decreasing order. 6 into 5 into 4 into 3, which is 360, children. Now, the question is continued. How many of them begin with 9 and end with 2? Now we got only the 4-digit numbers. But out of these 4-digit numbers, the first place should be filled with 9 and the last place will be filled with 2. Let us fix the numbers. See, look at the box, children. Now, the first place and the last place can be filled with 9 and 2 in the one way. First one is 9 and the second one, last one is 2. It is only one way which the question in the question it is needed. In between there are 2 places. And these 2 places can be filled remaining 4 digits. See the number of given digits, children. 1, 2, 5, 7, 8, 9. Out of these digits, only 9 and 2 are taken out. So how many are digits left? 1, 5, 7, 8. That means 4 digits are there. Out of these 4 digits, we have to take 2 at a time. From this 4, 2 at a time. What is that possible selection? 4p2. So filling up 9 and 2 is 1. And this method is, and filling the 2 gaps is 4p2. Product of this is 1 into 4p2, which is 12. 4p2 is 4 into 3 multiplied with 1. That is 12 ways. So how many 4-digit number that begin with 9 and end with 2, children? 12 numbers. For example, 9172, 9182, 91 like that, 52. You can form some numbers and check. That gives your that improves your analytical power, children. Find what are those 12 words that begin with 9 and end with 2 with a given form. That would enhance your subject and it allows you to do the assignment problems. Next problem, children. Find the number of injections of a set A with 5 elements to a set B with 7 elements. So we have to find the number of injunctions. In functions, we have seen injunctions and surjections. And injection between which sets, children? Set A and set B. Let us take set A, children. Consider set A. The elements of A can be mapped Let us take this as A, children. And in A, how many elements are there? 5 elements. Let us take these elements as A, for example, B, and this is C, and this is D, and now suppose it is E, children. Okay, this is all about set A. Now, sir is asking about set B. Let us take set B. In that, let us take some other elements, 7 elements. P, Q, R, S, T, U, and this is V. So these are the set A and B, children. Now the elements of set A is mapped with elements of set B. See, A can be mapped with P, A can be mapped with Q, A can be mapped with R, A can be mapped with S, A can also be mapped with T, A can also mapped with U, A can also mapped with V. So how many ways? The first element of A can be mapped to any one of the elements, 7 elements in 7 ways. AP or AQ, AR, AS, AT, AU, AV. These are the 7 ways. Suppose one of this combination is fixed, children. One of this is fixed. Then, for example, let us take AP is fixed. Let us take AP is fixed. Now, let us talk about B. After A, which is the letter B? Count the number of the letters available for small b in the set B. Q, R, S, T, U. Q, R, S, T, U. There are only 6 ways. Now, for C, there will be only 5 ways because he is talking about the injections. Once A is mapped to P, then B cannot be mapped to P because he is talking about the injections in the question. Because R is talking about the injections in the question, we cannot talk about the already mapped element. Suppose B is mapped with Q. What are the available elements for C in B? C can be mapped with R, C can be mapped with S, or C can be mapped with T, or C can be mapped with U. So the number of the ways will be decreasing. First 7 ways, next 6 ways, next 5 ways, next 4 ways, like that. So total how many ways it will be? 7, P, 5, proceeding like that. Because we have 5 elements in set A, we have to select 5 out of 7 in from set B. So the number of permutations will be 7P5, which is 7 into 6 into 5 into 4 into 3, which will be 2520. So we get the number of injections from A to B is 7P5. With this, we can also generalize if a set A has M elements and set B has N elements, then the number of the injunctions from A to B. Remember, children, A has M elements and B has N elements, and we are taking injunctions from A to B is NPM, which is very, very important formula for IIT. It is very, very useful. If IIT and MSET for competitive exam, it is very, very useful. And this is applicable only if M is less than or equal to N. In our case, M is equal to 5 and N is equal to 7. And if 0, if M greater than N. What happens if the number of the elements in A is greater than the number of the elements in B, then the number of the injections will be not related to this problem. If there are n things in a row, a permutation of these n things such that none of them occupies its original position. To rearrangements of n distinct things is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on minus 1 power n into 1 by n factorial is equal to 9. Sorry, is that formula. The 9 is by mistake. Find the number of ways. Using that note 2 will solve a problem. Then you will understand better, children. Find the number of ways in which 4 letters can be put in 4 addresses envelopes so that no letter goes into the envelope meant for it. Because it is 4-letter word, we will take 4 factorial, children. See here, n factorial. What is n here? If there are n things in a row. And then 1 by 2 factorial minus 1 by alternate plus minus denominator is 2, 3, 4, 5 and so on. Till where? Till 1 by n factorial, till n reaches. And its coefficient is minus 1 power n is equal to 9. Because it is 4-digit number, it is 4 factorial. And we have to increase the denominator 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial. Alternate plus minus plus minus. First one is plus, 1 by 2 factorial coefficient is plus, 1 by 3 factorial coefficient is minus, 1 by 4 factorial coefficient is plus, like that. Till the denominator reaches n factorial, that is 4 factorial. Then it is 4 factorial is 24, 1 by 2 minus 1 by 3 plus 1 by 4 factorial is 1 by 24, on simplification of which it will be 9. Dear children, with this we end today's class. And we have finished all very, very important examples that we have in permutations before starting exercise 5A. Today's assignment is complete exercise 5A first bit 6 problems. In first bit we have 6 problems basing on the examples given in the textbook and examples that we have discussed. So today's assignment, please solve exercise 5A first bit 6 problems, children. Thank you all. Have a great day. Happy National Mathematics Day once again.